Welcome to 2014 question A-3. It's a conics question. Okay. 3D graphic below shows a tangine, which is a type of clay oven frequently used in North African cooking. Right, so not too important, right? But just to know that's where this is coming from. The drawing on the right shows the incompleted elevation of the tangine. So here's an elevation looking at the tangine. The upper lid is based on two semi-parabolas, okay? So which are inscribed into rectangles, and the lower dish is based on a semi-ellipse. So they're telling us here and here are going to be semi-parabolas, and here is going to be based on an elliptical shape. V1 and V2 are the vertices of the semi-parabolas. P is a point on the semi-ellipse, so here's a point on our semi-ellipse, and there are the vertices of our parabolas. Small portions of two of the curves have already been drawn. Complete the elevation of the tangent, clearly showing how to find the exact length of the base. Okay, we have a flat base here, so we need to find exactly where that line finishes on our curve. So I'll jump to the top first and do the parabolas, and they've actually shown us the construction there already, which makes life a little bit easier for us. So typically what we do is we divide this line into equal parts and this line into equal parts, and then we can draw lines parallel to our axis and our lines running up to our vertex. But because they've actually given us one distance for each of those, we can actually get our compass. We'll just step off those distances, and they should be equal in measurement. 1, 2, 3, and yeah, right, so that finishes on the base there of the parabola. Okay, so I've got a point at each of those. And we'll repeat the same thing here for the points running away from the axis along the base of our parabola. And yeah, that matches up perfectly. So what I'm going to do next is I want to draw my lines parallel to my axis. So parallel to my axis there. Okay, and then my lines running up to my vertex. That's a point there. Okay, so that is after finding the points on my parabola. If you're not sure, index them. So we've got 1, 2, 3, 4. 1, 2, 3, 4. So 1 and 1, 2 and 2, 3 and 3, 4 and 4. So I'll draw in my parabola there. Okay, now this is also a parabola. I could go through the exact same construction, but if we look here, we've got a center line or an axis line there. So that's telling me that everything here matches everything over here. So I can just take those distances and do an axial symmetry on either side of that line. So staying through there. So you slide and set squares, or drawing a horizontal line in this case. And then I can get the distance from my axis of symmetry and find that point over here, and repeat that for each one. And I can draw my curve there. Okay, so that is the two parabolas completed. Next, we want to look at the ellipse. Okay, so I'm going to draw the full portion of the ellipse first of all, and then we'll come back and find that exact length. So they've given us our major circle, minor circle, and they've even shown us how to find the point. So what I'm going to do is go at 60, 30 degrees. This is our junior cert construction for a tangent, or for an ellipse. Okay, it's probably unnecessary to draw the whole ellipse, but just to show you. So where I hit the major circle, so where these lines come out and hit the major circle, I draw towards the major axis. That's all I found, yeah. Okay, so if I want to draw the full ellipse, it would come down here, hit my minor axis, and back up, like so. Okay, but they want us to find the exact length of this base. Okay, so what we're going to do is that same construction, okay, we're going to use that and kind of work backwards. So I'm going to imagine where this hits the minor circle, just extend that on so we can see that. I'm going to draw from there out onto the major axis. Okay, and I'll do the same on, actually no, I can just transfer the distance. Okay, then I'm going to draw vertically, same as I did with the other points, and extend that out. So right here, that is going to be the exact point that my base intersects my ellipse. Okay, I'm just going to highlight that construction for the examiner. Okay, and I can repeat the same thing on the same side or on the opposite side, or once again we've got our symmetrical, or our axis of symmetry, so I can mirror that, or yeah, mirror, I suppose if you're linking in your CAD, mirror that distance to over there. Okay, and that's my base, so I'll just draw my base in heavy. Okay, and I'll finish off drawing my curve there. That point. Okay, so that is how I find the exact length there. So it's by using the same construction we've always used, but finding that point on my minor axis. Okay, next up then, they're asking us in part B, so let's take this off. So part B, they're asking us to draw a tangent to the curve at point P. So here's point P, and I want to draw a tangent at that point. Okay, so what we need to do is we want to find our focus points first, or focal points. So my major axis runs from one vertex to the other. So half my major, I'm going to get that on my compass, and I go to the edge there, one side of my minor axis, and I swing an arc. That's going to find one focal point, swing an arc, that'll find a second focal point. Okay, so that's F1 and F2. What I'm doing then is, from both of those points, draw through P, and draw through P again. I'll just highlight this construction also. So draw through P. And what I'm going to do is, that angle that's created, I'm going to bisect it. So this is our junior circle construction for finding a tangent through an ellipse. Highlight that for you again. And here is my tangent at point P. Okay, so that's our conics question there on 2014.